All right, so welcome to the next video on truss analysis. So in this video, we're going to look at the idea of member forces. So these are our members. So our members can either be in compression, where the arrows are going towards a pin, or like compressing the pin, you can think of it, or they can be in tension, where the arrows are facing inwards. It's really important to understand whether the members are in compression or in tension. And it will all depend on what external forces are acting on the truss. So just keep in mind, at the joints, we have pin connections, and these pin connections, they can't carry a moment. So there's no moment carried at the pin connections. We can only have forces along the members, and that's what we need to analyze and we need to calculate. So a really important thing is to visualize a way to calculate these forces really quickly. Just imagine we have a force acting in a certain direction, say in this direction, and we have our X and Y axis here. So we have our X and Y axis. So this will be our X and this will be our Y axis. And let's say we're given an angle of 30 degrees here. So we should know that this remaining angle is 60. So this force has a Y component and it also has an X component that we need to calculate. So we need to convert this force into its X and Y components. Then we'll be able to analyze any forces in any direction. So there's a really simple way of looking at this force. So say, for example, this force is 10 kilonewtons. We need to figure out how much of this 10 kilonewtons is going to be distributed to the Y direction and how much will be distributed to the X direction. So to find our X direction, all we need to do is multiply our 10 kilonewtons by cos of this angle, and this will give us our force in our X direction, which will be 8.7 kilonewtons roughly. And if we want to find in our Y direction, we can do the same thing but use a 60 degrees. So we can write 10 times cos of 60, and that will be 5 kilonewtons. All right, so let's have a look at this example and let's find the forces from this pin, from our point B. Let's just find the forces here. So the first thing that we need to do is assume the member forces or what direction they are in. For me, how I like to do is I like to assume that all the forces are going away from the pin. So if we're going to analyze joint B, I'm assuming that all the forces are going away from the pin, so away from the joint. And we'll call this force BC, right? So we have force BC, and this one will be force BA. So first thing that we need to do is we need to write our equilibrium equations. So we have sum of forces in the X direction will be equal to 0. So we're looking at any forces going forwards and backwards. And we'll say backwards negative, forwards will be positive. And then we have sum of forces in the Y direction will be equal to 0. So any forces going up or down. So we have up will be positive, down will be negative. So if we look at our forces in the X direction, we have a 500 newtons going in the positive direction. So we can write that. We will write 500 newtons. And then we have our FBC. So we need to find the X component of this FBC. So a part of this FBC force will be going in this direction. We know that this angle is 45 degrees here, so this angle will also be 45 here. So we can write plus FBC multiplied by cos 45. This will all be equal to 0. So we rearrange to solve for FBC. We have 500 newtons divided by cos 45. That will be equal to negative 707.1 newtons. So if we have a negative value, this will be in compression. So always write if it's compression or in tension. So now we can do our sum of forces in the Y direction. So we have our FBA going in the negative direction, right? It's going down. So this will be negative. So we'll write negative FBA. So it's really important that we assume, we're still assuming, we'll still use this original drawing and we'll assume that this is in the negative direction as well. So this will be in the negative direction and it will be going down. We can write negative FBC multiplied. This angle will also be 45. So this will be cos 45 and is equal to 0. So if we rewrite this, this will be negative 707.1 cos 45 is equal to FBA. These negatives will cancel out and we'll be left with a positive 500 newtons is equal to FBA. So if we redraw our forces here, we'll end up with something like this. We'll have an arrow, this member will be in compression. FBC is equal to 707.1 in compression. And this will be 500 newtons. And it'll be in tension. So for example, now we want to analyze joint C. We can extend this, and this arrow will be pointing in this direction. And we don't know the forces of this member, so if we wanted to analyze it, we can just assume that this arrow is going in this direction. And then we can solve, and we can continue solving and analyzing the rest of the truss.